Next, we'll turn to TACC, and I'd like to introduce Tim Cockerill, who will give an overview of the TACC resources. Tim, are you ready?
Hey. You hear me okay, Scott?
We hear you, and we're watching Dean, and not you.
Oh, we're watching Dean.
Okay, now we see you. Take it away, Tim. Thank you.
All right, thank you, Scott. I'll do my best here. Also, to try not to overrun my time. I do have more slides here that I'm going to be able to talk about, but you'll be able to go through them at your leisure in the future. Come back and review these things. Quick overview of TACC. We have about 185 people now. In 2001, there were about 10. So we've had a pretty steady growth over the last almost 20 years. Our facilities include a sizable data center, about 10,000 square feet, that houses several different high-performance data and compute systems. In addition to those resources, I want to absolutely start with what I believe is our most valuable resource, and that is our staff. Similar to some of the other descriptions you've heard from SciNet and PSC, we provide consulting services if you need help with your code, if you need help compiling, code optimization, anything that you're looking for, parallelization. You can come and work with us, and we'll help you have people help you with your code, curating your data. We also have several data collections that we maintain, and we also we have a lot of software development activity where we provide portals, science gateways, for folks that want to share data more easily, or also maybe are working with scientific communities that are less command line savvy. And we also have a lot of web service APIs that we build off of what used to be called the Agave platform. Now we refer to it as the TACC API service, or TAPIS, to bridge between portals and infrastructure. And of course, we do a lot of training and outreach. But I'm going to try and spend the rest of the time here just really looking at the hardware that we provide. We have a very broad ecosystem of capabilities here at TACC. Of course, we've had Stampede 2 for a few years now, which was the #1 academic system. And it's now #2 because we've put Frontera in recently. And I'll spend most of the time talking about that, because I think that's what people really want to hear is, where are we going with Frontera, when's its availability, and really what is Frontera in its entirety. Well, you can see we have a number of other systems here as well. And so there's not only high performance computing, but we also have some data analytics systems, AI systems, and a variety of storage systems as well, for everything from tape archive to systems for large data collections, and then shared data infrastructure so that you can easily get at your data on all of our systems. We mount a file system within the entire data center. Several experimental systems as well. So some of these are FPGA, some that have some ARM, low power, Xeon type capabilities, a variety of different capabilities that you can do to explore different types of system architectures. So we have a lot of the existing infrastructure, but what's coming now, right? So Frontera is deployed at this point. We're in the early user period at this time. And that's the main system, and I'll describe that. We have some AI capabilities coming online in the next couple of months that are also part of the Frontera ecosystem, and I'll talk about those as well. But the primary system itself is a Dell Intel with Mellanox interconnect. It's about 8,000 nodes, and it's the Intel Cascade Lake. This is intended to be a system that most codes can very quickly move to and come up and run very quickly without a lot of extra work. So That's been very successful so far. The initial 36 awards from the National Science Foundation to get onto the system have all very quickly come online. Their codes are up and running and things are going out pretty well. And we just let people on just barely over a month ago. So you can see all the description of the system there. I'm not going to read it to you. And then, so the main processor is the Intel 8280 Cascade Lake. These are 28 core processors. We're running them close to 3 gigahertz. This is a water-cooled system so that we can run these a little bit faster than we have been able to run some of our other processors in the past, our air-cooled systems of these with large core count processors. So again, quickly through this, I'm not going to go through all this in detail. I only have 5 minutes, but these slides, as I mentioned, you can check them out later. The GPU systems, AI, this is, I think, what people are going to want to also see. These are not up yet. They're coming later this year, but both of the systems are being installed as we speak. So we have 2 of these systems. One we're calling Longhorn. It is not a part of the Frontera infrastructure, and I'll explain that in a minute. It is a separate system, but it will be allocated alongside of Frontera and made available to the Frontera user community. This is a very high-end system, IBM Power 9. It's got the EDR interconnect, and this has the 4 V100s per node with the NVLink interconnect on those as well. So this is a very high-end AI system that you'll be able to get access to. Should be available by July. That needs to come off of here. I don't know why that's on there. This must be an older slide. We expect within about 2 months to have this system available for allocation. Frontera GPU is a separate AI capability system, and this is more of a commodity type approach as opposed to the IBM system. So on this system, we have NVIDIA RTX 5000. This is mainly to run single precision, so it's a much less expensive alternative, but really very fast, very capable AI system. One of the interesting things about this system is also GPUs run pretty hot. This is actually a mineral oil cooled immersion system. So we've got the Green Revolution cooling, or now I guess they just call it GRC, tanks with mineral oil. And so this is a nice green system as well, energy efficient system. Both of these systems, the previous systems, the GPU systems, as I mentioned, will be available in the fall. And I'll talk about allocations in a minute. In addition, we've got cloud support as well. So we do have an agreement with agreements with AWS, Google, and Azure to integrate with the cloud services. And so there's a little description here, but essentially if you need to offload some work into the cloud, or there's some capabilities you have there or data you have there, we're going to be integrating very tightly with the cloud providers as well. We do have a large tape archive here for large multi-petabyte storage. A lot of the Blue Waters folks have had a lot of data that they generated, and they're moving all that data here. All right. Allocations, this is what everybody wants to know. When, how? At this point, we're proposing the following. So I have to say proposed. We're pretty confident that this is how it's going to look in the end. But the NSF, as with Blue Waters, controls a chunk of the allocations process. And that's referred to as the PRAC, or the Petascale Research Allocations Committee. That we believe will still continue. But then how else can you get on the machine as opposed to just working through that PREC and being already being a large scale. So we wanted a way that people could move into and prepare themselves for that process for the PREC. So we have something called pathways. So if you have some large scale science that you want to accomplish in the future, this is a way that we can help you get there. Then we have what we call large community. This is for large connections with the large facilities office at NSF. So the large projects like LIGO, who often don't have enough computing built into their budgets to do all the work that they need to do, we're going to be partnering with them. And then, of course, with all NSF systems that are typically through Exceed or similar through the OAC at NSF, we get discretionary time. And so we're going to have a process by which you can reach out to us to do that. None of this is in place yet. Stay tuned, watch the Frontier website, and we'll be letting you know when and how all this becomes available to you. So, so where are you at today? So if you're ready to run 10,000 plus cores, you're going to be able to come to us actually now and reach out to us, and we'll take a look at this without having a process in place. We do have director discretionary, so you can reach out to us personally. You can send me an email, or you can go through the ticketing system here and reach out to us, and we'll engage if you're already running at large scale. And my 5 minutes, or at least are up, I think, at this point. So I'm going to leave it at that. So thanks, everybody. And my email is there. Feel free to reach out. Thank you.
Thank you very much, Tim.